start at the direct modeling level with one of the early strategies that students will use, and that is to draw a picture or use counters or objects. So our first question is, Isaac had 6 balloons and Delaney gave him 4 more. So first we need to demonstrate his original 6 balloons. 1, 2, 3, 4, 5, 6. Delaney gave him 4 more. 1, 2, 3, 4. How many balloons does Isaac have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is a very simple direct modeling representation of some single digit addition. So now let's do single digit subtraction. So Isaac had 4 balloons. 1, 2, 3, 4, but 2 of them popped. 1, 2. How many does Isaac have left? He has 2 left. So that is a direct modeling using objects or pictures of single digit addition. Obviously, this works the exact same way with double digit addition and subtraction, with the exception or with the caveat of it just taking longer. If you think of students drawing this out, it takes longer, you're more likely to make mistakes. So that's why it's important to move our students through to more efficient models. So for this problem, we will do 3 plus 4. Context that I could give to this, I mean, there are so many things. Charlie had 3 candies and Tayson gave her 4 more. So I'm going to show Charlie's original 3 candies. And then the 4 more that Tayson gave her. So it can help to use different colors for this so students can see, oh yeah, I already added the 4 that Tayson gave her. So Charlie had 3 candies. Tayson gave her 4 more. How many candies does Charlie have now? Or 3 plus 4 equals 7. Kids will become very proficient using tens frames because they know it holds 10. Use of a tens frame can also help students build those basic facts like we talked about in a previous unit. So students will look at this and they will know, oh, it's a tens frame, but 3 are missing, so that's 7. So they will automatically start to build that basic fact fluency. So that's one way to use simple single digit addition with a tens frame. And you can use subtraction in very similar ways. So Charlie had 3 pieces of candy and she gave Tayson 2. So I'd start with the 3 pieces and I would remove 2. So 3 minus 2 equals 1. And then obviously this is going to be quicker with a single tens frame, and they're more efficient models for doing double digit addition and subtraction. But I think it is important to also show students how we can use this for double digit. So for the first one, I can say, and we'll do double digit addition. Charlie walked 12 miles. So obviously, because each of these only hold 10, I am not going to be able to fit all 12 in one. So I will fill up the 10, and I know, okay, 12 is 2 more than 10. That just goes back to basic number sense. So 12. And then on Tuesday, she walked 4 more. You can use same or different colors. I'm just going to use same. Tuesday, she walked 4 more. So while I can see the 4 more in here, it is going to be easier for me to calculate the total if I just continue putting those in the other tens frame. So I know 10, and I know half of 10 is 5, so 10, 15, 16. So then 12 plus 4 is 16, or Charlie walked a total of 16 miles. And I can do the same thing with subtraction. So Charlie walked 16 miles, or I can say Charlie had 16 gummy bears. She gave away 5 of them. 1, 2, 3, 4, 5. So I know Charlie only has 11 gummy bears left. So 16 gummy bears minus 5 is 11. So that's, the tens frame with basic addition and subtraction, single digit and double digit. That it is easier to move to higher numbers with base 10 blocks than it is with a tens frame or pictures. It is more efficient. So for the first one, you can do single digit because there are ones. But really that's not much different than just drawing a picture or using single objects. So for the first one, I'm going to stick with double digits just because there are easier, more efficient strategies for simple single digits. So, for example, I'm going to say Charlie had 16 gummy bears, 10, 11, 12, 13, 14, 15, 16, and Tayson gave her 12 more. 10, 11, 12. Now, the easiest way to do this would be to put the tens next to the tens and the ones next to the ones, but not every problem is going to be set up so easily. So it's important for our kids to be able to count, to be flexible with how they count and calculate. So I can say, okay, 16 plus 12, that is 10, 20, 21, 22, 23, 24, 25, 26, 27, 28. So I know 16 gummy bears plus 12 gummy bears, or 16 plus 12 is 28. So I can also use base 10 for subtraction. And again, this is another direct modeling strategy. They can do it hands-on. Eventually, you can move this to a more invented type of strategy where they are drawing it, but it is still related to a very physical tool that they've used. So for subtraction, I can say, okay, 16 minus 5. So if I had 16 gummy bears and I gave 5 away, 1, 2, 3, 4, 5. I know that I only have 10, 11 left. So 16 minus 5 is 11. You can also use this for numbers that may require regrouping. So if I said Tayson had 14 books and his teacher gave him 7 more books. 1, 2, 3, 4, 5, 6, 7. So if I counted 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, wait, that's a new 10. I can regroup all those ones I just counted up to 10 for another 10 rod. And I am left with 10, 21. It works similarly for subtraction. So if I had 15, or let's say 13 minus 9, I could say, okay, so I have 3 ones. I don't have enough to take away 9 ones. So let's change in my one of my 10 rods for 10 ones, because whatever you are regrouping it for needs to be equivalent. 6, 7, 8, 9, 10. So then I can take away my 9 from the ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I am left with 10, 11, 12, 13, 14. So then I know that 23 minus 9 equals 14. So those are some of the most common direct modeling strategies that we'll use. Obviously, the further we go along, the more efficient they will be with larger numbers. So with smaller single-digit numbers, yeah, it's okay to start out with the pictures. But if you tried doing that with multi-digit numbers, it's going to be less efficient.